Okay, so here are the notes for section 10.6, secants, tangents, and angle measures. There are three theorems in this section. Really, I mean, there's three ideas, and they're not very complicated, but there are some kind of tricks to them that you have to learn. So we're going to introduce the idea of secant lines. We've already talked about tangent lines, and now we're going to talk about angle measures. So you found measures of segments formed by tangents. Now we're going to talk about measures of angles. So first of all, a secant line. So it's pronounced secant, like as in S-E-E-C and then can't see. So secant is a line that intersects a circle twice. So we have line J and line K. Both of those are secant lines. A tangent line, remember, intersects only once. Okay. So definition-wise, that's what a secant is. Here's the first of the three theorems. The first one is you have two secant lines. This is line DC and line AE, and they're intersecting inside the circle. Now, hopefully, this comes out clearly enough. But what ends up, and I should have done something so I could pause this. But what happens is when these two lines intersect, they form an arc at DE here, and an arc at AC here. Okay. Now, those arcs you can see are right here. Let me highlight that for you. Highlight arc DE and arc CA. Now notice, just look at those numbers for a second. Those arcs are never congruent. At least almost never. There's a moment where they do run to each other. One time it's big, one time this one's smaller, sometimes it flips. But notice angle ABC in the center and angle DBE in the center. Those are both the same every single time. Okay. So the question is, how do you find what those two angles are? Or are they related to the arcs? And in fact, they are. I know this statement here probably is kind of confusing, but look, here's arc DE, here's arc AC. If I take DE or AC and DE and I add them together and I divide it by 2, which really is just averaging them, I get the measure of whatever this guy is. So that's the theorem. So again, it's probably kind of hard to understand with the drawing, but the idea is, and when you see the single drawing when it's not moving, it'll make more sense, but I just wanted to give you the numbers to look back to. These two arcs here, their average is the same as these two angles right here. Okay. Now the next one, okay, we have a tangent line here. This is IJ. That is a tangent line. Okay. And then I have this line here, HM, which I'm going to call or think of, it's a secant line if we're to continue forever, but I made it just a ray. So it's a secant ray. So the question for the next theorem is how is the angle related, HMJ or HIJ, they're both at I and M. How is HIJ related to its arc? Well, here's angle HIJ right here. Here's its arc right here. Okay. And the angle is half of the arc. Okay. So this angle formed from here to here to here is half of the arc around the circle. It works that way every single time. This is always equal to this, and that's always half of the arc. Now the last theorem is whenever you have two secant lines that intersect outside the circle at point T. They always create two arcs of their own. The blue arc, which is PQ, and the red arc, which is RS. And RS and PQ, okay, aren't equal to angle T. So angle PTQ is 36.08. But what it is that angle PQ or arc QP minus arc RS divided by 2 is equal to that angle. So these two guys are equal. Okay. So here's the deal. I got this little table in your book. Okay, a little table in your book, or in your notes. And basically all you have to know for these three theorems is where is the vertex for the angle that we're trying to find? Is it outside? Is it on the circle? Or is it inside? Because depending upon where it's at, that's what the theorem is. So if it's inside, like it is for this first one, it's half the sum of the two arcs. Okay. If it's outside, it's half the difference of the two arcs. So the difference divided by 2 the sum divided by 2. And then the last thing is, okay, if your vertex is just on the circle, you're just half the arc, just like an inscribed angle. So here it is. It's theorem 1012. It'll flash up in a second, or you can just copy it from your textbook. But the question is, where's the vertex formed by the 2 secants? Well, it's inside the circle. That's theorem 1012, so it's half the sum of the arcs. Where's the vertex? It's on the circle, which is theorem 1013. Then you're just half the measure of the arc. And if you're outside the circle, that's theorem 1014. You're half the difference of the arcs. Okay, so here's theorem 1012 formally. The measure of angle 1, since the vertex is inside the angle, or inside the circle, is half of AB plus DC. So angle 1 is half of AB plus DC. And then angle 2, which has BC and AD as its 2 opposite arcs, it's half of the sum of those 2. Okay. Theorem 1013, this one's on the angle. So if vertex is A for angle 1 and B angle 2, their vertex is both at angle is at 1 and 2. Well, that angle is for the angle 1, it's half of its arc it cuts off, which is AB. And angle 2 is half of its arc that it cuts off, which is angle BCA. And then here's the trickiest of the 3, and it's really not that tricky. You just got to know what you have for the circle. And we'll look at a couple examples like this, and then we'll look at more in class. Angle A is outside. So you take DE minus BC and then multiply by half. And DE is the one that's farther away, and it's always the bigger one. Notice the one farther away from the angle A is always bigger in its arc. This angle's farther away from this arc. This is the smaller arc. So DE minus BC times a half. DC minus BC times a half. BDC, because it's a major arc now, minus BC times a half. Okay. So first example. So, solve for x. Okay. The vertex is in the inside of the circle that we're looking for, so that'll help us out in solving for x. Okay, so first example. This one is actually normally the easiest, but this one has a little weird trick to it. So the first thing I would say is, oh look, the vertex is in the middle, inside the circle. So this angle is half of the sum of its 2 arcs. So this is the angle I'm looking for, which is congruent to this angle, but these are the 2 arcs I need. Problem is, I don't have those 2 arcs. So what I'm going to have to do instead is actually solve for this angle and use these 2 arcs. So I'm going to call this y. Okay. So y equals 1/2 of 68 plus 102. Okay. 1/2 of 170, which is 85. Okay. Well, this angle here is 85 degrees, but that's not the angle I want. I want the angle next to it. Well, they make a line. So they're a linear pair, so they're supplementary. So x is 95 degrees. Okay. That's the easiest theorem, but that's the hard form of that theorem. Okay. Next example. Okay. So looking at this one, I'm trying to solve for the measure of arc UVW, and I have a vertex now of this secant line and this tangent line, but the vertex is on the circle. So there's your hint. Okay, so here we go. Let's look at the problem. So I am looking for the measure of arc UVW. Well, here is UVW. Okay. So, but the problem is the angle I have, the 99 degrees angle, which is this angle here, this is its arc. Okay. So I'm not going to be able to directly get to that one either. So what I'm going to have to do is realize, hey, this angle is half of this arc, because again, it's on the circle, just like an inscribed angle. If your vertex is on the circle, you are half of the arc. So 99 is half the arc. Okay, so multiply by 2, and you get 198 is x. So it's 198 degrees there. Well, this is the rest of that, so it's 360 minus 198, which ends up giving us 162. So that's the measure of arc UVW. All right, just moving right along. Let's see in the QS. All right, next example, find the measure of arc QS. Okay, so this time, the angle I actually know this one this time, but it's outside the circle. So that's your hint for this one, it's outside the circle. Okay, so here we go. So I'm looking for arc QS. Okay. Well, the angle that I have to work with is this angle right here, angle R, which is 56 degrees. But it's outside the circle, which the one that's outside the circle is half of the difference of the arcs. Well, the other arc is arc PT. Okay. So, angle R equals 1/2 of PT, because it's the further away, which means it's a bigger one, minus QS. Okay. So the angle R is 56 degrees. PT is 135, and we're just going to call QS X. Okay. Now you could distribute the 1/2 in, but to be honest, don't do that. Instead, multiply both sides by 2 to cancel this guy off. So you get 112 equals 135 minus X. At this point, some of you might be pretty good at mental math to figure out this is 23, but if not, subtract 135. That gives us negative 23 equals negative X. Divide by negative 1. So QS is 23 degrees. Okay. All right then, last example. So we're trying to find the measure of arc FIH. Well, again, just like that last example, this time the angle we're looking at, the secants form to, is outside the circle. So here's the deal. I know this angle, 50 degrees. Here's one of the arcs it forms, 130. Okay. I'm supposed to find the other arc. Okay. Well, again, if it's outside, angle G is 1/2 of the difference of FIH and FH. Okay. So G is 50 degrees. FIH is 130. And FIH I don't know, excuse me, and FH is 130. Okay. So I would double it again, just double both sides, cancel it off. 100 equals X minus 130, add 130. There you go, 230 is X, so FIH is 230 degrees. And that's that. So I know these are more complicated. I know these are more complicated and might have struggled a little bit, but that's fine. We're going to go through all these in class and you'll figure it out by the end of the hour. It's not that bad.